In this video, I want to go through the Table.FillDown function and also the table fill up if your dataset requires that. This function will replace nulls with either the value above or below, and in cases here where we have multiple nulls, it will still grab the value above until it finds a non-null value. I want to recreate this function with multiple methods, some of which are recursive lookups, and then I want to solve it with List.Generate to avoid that. We need to solve the problem where the previous row is also a null. We can start with the simple solution using the functionality that already exists, which is simply to right-click the column and say fill, and in my case I want to fill down, meaning I grab the value above. In my dataset I have inventory stock. Some days I might not have counted inventory, and if so, I'll assume the count is the same as before, which is not correct, but let's just do it that way. We can start out by doing a recursive lookup where I want to first do another reference. In this case I need an index column which has to start from 0 because I'm doing a list lookup, and lists start from index 0, meaning I start out by adding the index. I'll do the lookup in a new column, but you could also replace the existing column. I'll need to refer to the current table in order to do my recursive lookup, meaning I'll start out by simply outputting 1 because now I can change the name of this step and then I can refer to the table inside of my function. I want to not have any spaces because then I can reference the table without the hashtag quotation mark syntax. Now I can say function is going to be, I want to say that first if the stock isn't empty, then I want to grab that value. I can say if not, and then in parentheses, because then Power Query will do the calculation inside the parentheses first, which is going to output a logical, and then I can inverse that, meaning I first check if stock is null. And then if it isn't null, then this will output false, which I then turn into a true. So if there is a value, then I want to output the value. Otherwise, I want to do my recursive lookup. For now, we'll simply output 1 in order to test the first part. So here in all of the rows where I don't have null and I don't have no data, I get the value 1. Now we can do the recursive lookup. As mentioned, I want to refer to the current table because I'm going to fill this column iteratively, I hope. Meaning that when I'm here in row 7, I'm going to look into row 6, and then when I'm in row 8, I will look in row 7, but row 7 has already been filled out. Meaning this solves the problem where I have multiple nulls in a row. When doing recursion, I need to add the @ sign in front and then my table name. I then want to do a list lookup. I want to grab the value in the index column in the current row, and then I have to say -1 to grab the previous row. I'm going to assume that my first row always has data, but that might not be the case. This will then return a record, and I can then extract the value from the current column, which is called recursive lookup, so I'll copy that. And that was already everything. So I assume that behind the scenes, when you do this calculation, that Power Query will calculate one row at a time. So like a normal loop that you do in a normal programming language, where we first calculate row 1, then 2, and so on. But I can't confirm this. It's just, it would make sense for me to do it that way. We can also choose to change the stock column instead of adding a new column. And also it's going to have that error sign, which I think is just a result of doing recursion, where it gets a little mad. So it claims that there are errors, and if we count, it says 10, which is also the number of rows with nulls. So you can ignore that, but just ignore it. If we add a new step, it goes away. So just ignore it in the current step. It's just that recursion is a bit wonky. But as mentioned, we can use replace value instead of adding a column. I would probably prefer that unless you want to make it clear that you had to do a lookup. In any case, I want to replace table.add column with replace value. And I'm still acting upon the added index column, but now I'm not referring to this. I need to say what is my old value. That is going to be the original value, but actually I want to do my condition here. So I start out by copying that. And then instead of outputting the stock value, I want to output null instead, because in this case, I don't want to do a replacement. Actually, no, I want to change the logic to say that if stock is null, then I want to output null, otherwise false. And then I need a comma, because now the old value is a null, which is also the actual value in the cell. And we don't care about rows with a value, only those without. And then the actual condition is the same. Actually, yes. Then my replacement is going to be each. And then it's actually the same. I just need to remove the else, because when I do my replacement, I'm going to look for the value null, because for each row, I'm going to do this calculation, and actually I need the each in front. So for each row, I do this calculation, saying if the value is null, then I want to look for the value null, and if the value isn't null, then I don't care. Now I can say what replacer do I want to use? I need to use value, because I'm replacing a null, and I want to act upon the stock column. And if I did everything correct, then this is fine. Actually, no, it did no lookup, because I need to change the column that I'm doing a lookup into. Now it's fine, except it outputs type any, which is a bit annoying. What we can try to do is, right now we're being a bit lazy because we can manually input a function. When you use this replacer function, you actually have a 3-argument function, which is used inside of the replacer, which we can see the value old and new. But if we make this explicit, we can say current, old, new, where current is the current row, where we then do a lookup into the stock. So actually it's the current row in the stock column. The old value is defined here and the new value is defined here. So these are passed in as variables inside of the replacer function. And by making this explicit, we can say what is the output of our function, which is going to be number. And then this is going to be mad because we haven't told what to use inside of the replacer. We also have to specify that, but we simply pass in the variables as before. So now we get the desired output, and we can see here that the column still thinks it has empty rows, which is again a problem with recursion, where Power Query is a bit confused. If we simply add a new step, it updates, because now the previous step has been calculated. Basically, it's kind of in a state of flux where it will replace the value, but then this condition is no longer true because there is a value, but then because there is a value, it doesn't replace the value, so it's an Ouroboros. It's just best not to think about it. In any case, we can now move onwards to the more fun stuff. I want to make a more general recursive lookup function because all of this has been hard-coded and that's gross. We want a generalized function that you can use in other queries. Once again, I will start out by referencing the table, and I still need an index column, which will start from 0. I can then make my function, which is going to have 3 arguments. I need to have a table, I need to have the column, and then I need my index. And since I want to refer to a column, I need to make sure that my function uses functions that refer to columns via text and not the square bracket syntax, because that will give problems inside of the function. When you pass in a column name as a text, you can't use that inside square brackets, because Power Query thinks it should look for a column with the name of your variable, not what the value of the variable is. So your variable might be called my column, and then you write square brackets, my column, square brackets. It thinks that column exists, but it doesn't. In any case, as mentioned, I want a table, which should be type table, a column, which should be a text, and an index as a number. And this is actually an integer, but we're going to ignore that. It's going to output. This is the same logic we used in the first instance with recursive lookup, where we say if not is null, then. But we need to use a function like record.field in order to use the data column to access the field. So we'll say in parentheses, because I need this inner calculation to be performed first to output a logical. So I'll use record.field. I want to go into my table and specifically the index column where I'm doing a lookup. And then I want to go into the field called my data column. And then I check if that value is null. And then I inverse the logic. And then if this is the case, then I want to output the value of the field where I can then actually copy this. My replacement is that I output the original value. And actually I made a spelling mistake. And if not, I want to do the recursive lookup. And actually, I forgot I need to name my function before I do this, because I need to finish the step in order to have a step name in order to reference it. So I will call that func recursive lookup. And now we can reference it. And again, by adding the @ sign in front. And I'm then passing in the table and my data column and my index, so I can copy those values. And then I need to say my index -1, because I need to check the previous row. And if I did everything correct, then I can use my function in a new step. So we're going to go back to the added index step and say I want to add a column to this table. I want to use the recursive lookup, which then passes in, and I then add in also the added index step as my table. And my column was called stock and my index is called index. And then I need to actually put that inside the parentheses. I'm actually doing a lookup inside the index column of the current row. So this shouldn't be in quotation marks, it should be in square brackets. And then I forgot to write each here, and then everything is fine. It is a number, but it outputs type any, which I want because you could have text inside the original column, meaning that you would need to add the type inside the table add columns function. In my case, that would be type number. This solution is bad because you're doing a lookup for each row, which is kind of gross. Because there's no reason to do a lookup into another table when you could simply grab the value here. So actually we could change this part to instead say that, well, if there is a value here, I simply want to input that in the new column instead of going into the added index table and doing a lookup using the index column. That's unnecessarily expensive because when you're inside of the context of table.add_columns, you have access to the current row and I want to use that. I want to take this function and then fix that. Now we can call it function 2 or function good, and then it should update. Actually, it didn't. We can simplify the function because I don't have to do a lookup. If my condition is true, that is, there is a value, we can remove that. And then because I'm not doing a lookup inside of that other table, I can remove this. And instead, I want to simply go into the data column, and then I want to treat that as a list, where I then do a list lookup like normal. And I don't need this curly bracket there. And then I still check if this is null, and then I invert the logic like before. Meaning if this is true and there is a value, then I want to grab the value from the current row. We'll change the add column step to do the check whether the value is null inside stock. And if it isn't null, then grab that value. And if it is null, then we do the function. That way we can simplify the code a bit. I want to change this to say that my data column should be a list instead. And then I'm going to buffer that inside of a variable. And I still need my index, which is going to be a number. So the difference is that this is a list instead, and then we can simplify the code a bunch. Then we don't actually have to do a conditional check because we do that inside add column. Instead, we simply do a recursive lookup. Well, simply, I'll say that we have to call this recursively. Actually, we do have to check because we do a lookup. If the value isn't null, I want to do a lookup into the list using my index as the value. And then I check whether this is null, and then I inverse it. Then I want to grab that value, which I just checked. Else I want to do my recursive lookup, where I just do a lookup into the previous row. So this comment is no longer true, and we can remove that empty line. And then we call it, and that's because I want to use a record. Then in here, instead of referring to the column as a text, we'll create a list. First I want to add a variable, which is then the stock column, which has been buffed. I want to go into the added index step and grab the stock column. And then I can use that variable in. I then want to say each. And then we do the same thing as before. If not stock is null, then I want to grab the value from the stock column. Else I want to do my recursive lookup. And then the recursive lookup is inside of the function itself. And then I need to enter that as my list. And index is still the same. And it should be a type number. So that is fine. And it doesn't give me that error, which is beautiful, because now the recursive logic is inside of the function. So this is less intimidating to call because the actual recursion is stored inside the function and you don't have to remember to add the @ sign. So I would prefer this. In any case, we can now move on to the final solution, which is not to use recursion, but instead to use List.Generate, which is honestly a lot simpler. Once again, we will reference it, and actually I should rename this with recursive function, good solution, and List.Generate, which is also a good solution. The way this solution works is that we iteratively create a list, one row at a time. This means that when we're in this 9th row, we have already added a value in the 8th row, and we have already added a value in the 7th row, meaning we are only ever referencing the current row if there is a value, or the previous row if the current row is null, which massively reduces the lookups, similar to this solution, where we only do a lookup if there is a missing value, meaning it is much better performance. In any case, we're going to do the same thing as before, where I want to store the stock column in a variable. I want to buffer that, and then I want to use List.Generate, which will create a list, and we have to start out with the initial, which is going to be a record, because I need a looper variable in order to reference the previous step. Well, it's going to make things easier at least. I also need to know when to stop. Yeah, an index is just going to make things easier. As always, the initial has to be an empty function, which goes towards. I'm going to call my iterator looper, start at 0, because lists are index 0 based. And then the actual value will be, I want to go into my buffered list and do a lookup into position 0. And I could also use the looper variable, but I think this makes it a bit more easy to follow along. Then we have to determine when to stop, which is also a function, and it's going to keep going as long as the looper value is less than the length of my buffered list, because my looper starts at 0. Then when the looper is equal to the length, then it stops. And because lists are index 0 based, it just works out. So that's perfect. I then have to calculate the next value, which is also a function. And because I'm outputting a record, I have to wrap this in square brackets. My looper is going to be the current value of the looper variable plus 1, because I go into the next row. And then my value is going to be, here I want to create a variable to make things a bit easier to understand, because this is going to be the current value. Actually, no, I don't think I'm going to do that, because I can also do a reference into the current calculation. So actually the way List.Generate works is you create the value of the next row when you're in the current row, which is a bit trippy. So once again, I want to use the construction we're used to, where if not, and then I do the current value, if that is null. Actually, I was a bit hasty. I do have to do a lookup because I'm actually generating my list one row at a time. So I have to do a lookup for each row. So I do want a variable here to make things a bit easier. I want to do my lookup. And here I use the square brackets against looper, which means actually inside of this context of value, I'm grabbing looper, this value, which has already been incremented by 1, which means this grabs the next row. So then I check if the next row is equal to null. I should probably add a note here, checks next row, and then we can do our check. If not, I need to add the variable here. So if not cur is null, then I want to grab cur, else I want to do my recursive lookup. And here I forgot to change the name of my step, but that's probably fine. So we'll do recursive lookup, and then I want to do a list lookup where I want to grab the value from looper and then say, then I need to end my record with the square bracket. This outputs something that gives an error. So I want to say that I want to output my value, not the looper. Yeah, this is one of those quirks with recursion. If we just delete it again, we can see it says error, but actually when you inspect it, there's no error. It's just recursion is very hard to visualize. In any case, this should be the same. We have 800 and then 666 and 600, 4 times, then 8, 5 times. So that is correct, but I just want to go through this once more. Yeah, I want to not have the square brackets here because actually what I said wasn't exactly true. When I'm inside of the context of value, that means when I refer to looper, I am inside of my record, which means looper without square brackets is this part, which is the current value of looper plus 1, meaning next row. So the comment is correct. So it checks the next row, and if the next row isn't null, so actually I should call this next. And if not, then it refers to the previous row, because square brackets looper refers to the current row sys value of looper, which isn't the current record. This is also quite difficult to understand, but it is fairly compact code. In any case, I now have a list, but I need to add that as a column into my table. The simplest solution is to use Table.FromList and Table.toList, where I first want to convert the original table into a list using Table.toList, where I can then say sheets 1. Actually, it's not toList, it's 2columns. Now I have my columns as a list, and then I can append my new list, my source list, which needs to be wrapped in curly brackets to be added as a list. Then I need to use the ampersand instead because I'm using list concatenation. And now I can then expand my list of lists using Table.FromColumns to go into my previous step. And then I still have type on my original columns, but I don't have type on my new column. We can add a columns as any step here. This needs a list. I will first use table.column names to grab the names from the sheet 1 table. And then I want to append a new name, which needs to be a list. I will call the new one fixed stock. And then we get correct column headers. And we had type in the original 2 columns, but we don't have type in the other 2. And it's a lot of work to add type inside Table.FromColumns because you can pass in a type table as the second argument, but then we need to create the type table. And this video is already too long, so I don't want to do that. If you want to do it yourself, it involves using table.schema to grab the column name and type, then using text combine to create a string, and then using expression evaluate to convert that string into a type table type. But yeah, the video is too long. So, yep,